Please don't fall into my scope. Welcome to the rig. It is a full moon tonight, so I'm using this opportunity because it's clear to do some collimation experiments on my 130 PDS, and if it's clear enough I might do a tiny bit of imaging, but we'll see. Full moon, not great conditions, so let's go around the rig. 130 PDS, and then I've got the 120mm, which is doing the guiding on an SV Bony 120mm guide scope. My really old EQ3 Pro, which is fine, and it should hopefully be absolutely perfect for the sort of test I want to do. I've got an Altair 269C and a Pegasus Astrofocuser, a 0.95 coma corrector stroke reducer in here, which I think is made by TS Optics. What does it say around there? TS, yes. So I think it's the Maxfield coma corrector stroke reducer, so that should reduce the focal length a tiny bit, so it should be quite a nice wide field of view from this particular telescope. Because it's been about 3 months since I've been able to get any imaging done, I did a test run of linking everything to my Astro PC inside, and I rigged everything and checked it all worked and that the drivers were working, so hopefully we shouldn't have too many connection issues, but I'm sure there'll be a few gremlins along the way, because there always are when you start imaging again. It's been a weird sort of 2 or 3 months. I've just finished a quarter of a century with my current employer, and I get a little bit of time off in sort of October, November, December time. So I'm hoping that there should be some clear nights and I'll be able to get some imaging done during those clear nights. I've signed up to do an astronomy module at the Open University, so I'm kind of hoping I'm going to get through that okay, but that will take me through to April next year, and I've got an exam and some essays and things to write, so some assessments. So I'm doing a bit of studying, which is a bit scary, but hopefully it will be interesting and I'll be able to get through the maths, because I've had a look at the workbook and there's a lot of maths, as you'd expect with any sort of physics or astronomy based course.
Andy! Andy!
What?
No! Pretend to be asleep. It's a dream sequence.
Oh, okay.
Andy, you will buy a Newtonian telescope, an 8-incher.
Well, they're all bendy and rubbish, and you need to do loads to them.
I don't care. Buy one. A nice big 8-incher.
Oh, all right.
An 8-inch, 1000mm focal length.
That's very typical of a GSO scope. They come double boxed, so box, inside box. There we go. This is a Stella Lyra 8-inch f5 Newtonian, and this is a quick tour that I'm going to make. So we'll start at the business end here. We obviously have a fairly standard focuser. It's actually not too bad, and these focuses come as standard with the correct compression, so you don't mar your eyepiece. So it's basically a special piece of metal that you can see there that stops it marring your eyepiece. So that fits in there, which is nice. I've not had any problems with these. The only thing that is a bit weird is once you move the focuser up, if you loosen this, let's do a little bit lower, if you loosen this it will pop back down. There we go. So that's your focus tension there, and you'll also notice that this is curved. Now if you were to get a focuser to go on this, which I will be, you need to somehow make that flat so that your focuser can be properly clamped on. I'll probably 3D print something to make that flat, but I don't know why they make those curved, but they do. So already you have to do a little bit of modification. I knew about that with this particular scope. On this side you've got a focus lock, so if you're using this without a focuser you can set focus and then lock it, which is useful for using this for visual, because if you push the eyepiece in or out you can have it locked with that knob there. Then these clamp the 1 inch to 1 1/4 in there, and again these have the anti-marring metal that you can see there, so that's good as well, so you won't damage your cameras and your lovely eyepieces that cost you a small fortune. So that is quite good. It's nicely constructed. I mean, it feels quite solid, and although there's always a join there, I'm slightly more confident about this join than I was with my Skywatcher one of these, and although I will put tape around this to stop light leaks, I think that's slightly better built. Let's open up and see what the spider looks like. Not a lot to see in there at the moment, but fairly standard spider with some screws, and looks like quite a nicely built spider actually, so that's quite good. I won't let the dust get in. And then as we go to the other end, this is where it's significantly different to a Skywatcher one, in that it has actually great big chunky knobs here, which I'm not worried about moving these because it'll be hopelessly out of collimation, as all reflector telescopes are when they've been in transport. So basically these are the locking ones, these lock, and the black ones are for adjusting. I have seen that some people are not particularly happy about these springs. Can't really see them there, but there's a spring just there which is not particularly loose, but it's not the strongest spring. I am liking having a fan. The power socket is there, although I think if I had a power plug standing out I would probably snap that off very easily because I'm really clumsy, so I might have to come up with something that does a right angle, just I don't know whether I'll use that. And then, as per all Newtonians, the mirror cell here will allow light to go around the sides, so this has to be covered. There's no question about that, you have to cover this. So the fan will be good for cooling down, but then I'd probably stop it, although they're also good for removing dew. It's very shiny. Much better paint finish than my other 8-inch. And it feels smaller. But that's probably because I haven't got the tube rings on and I haven't got the dovetail bar on as well. So they will have to be fitted. So you must all be thinking that I'm absolutely insane buying another Newtonian. I'm not insane buying a Newtonian. I really like Newtonians, but I had a credit note to spend and this was just burning a hole every time I saw it. So I thought I'd take a punt on a Stella Lyra version, and from my first impressions it's better built. There are a few things to do, as with all Newtonians, and I think this might be a nice scope, but there's a lot to do to get this ready to image. These are the accessories that came in these boxes here. We have a nice red anodized dovetail bar. We've got the 2 telescope rings to support the telescope, which will be screwed on with these screws here. And then I'll also put on the top of the bar a guiding bar as well, so I can put a guide scope. It comes with a battery box for the fan. It comes with an extension tube, which again has the anti-marring brass inside, and in the box you can see it has the second thumb screw, which just fits into the side, just there. And then this is the finder scope. I'm not going to open the finder scope because I'm not necessarily going to use the finder scope, so until I have a need for it, I'm just going to keep that in its packet, keep it fresh. And then this is the finder scope bracket to support the finder scope. And that's everything that came in the box. So the next job is to build this telescope. Okay, so looking at this, these are a standard M6 bolt which they provide there, and on this side you can see it's quite a substantial piece of metal, so that's quite substantial there. They kind of match up a bit. I mean, they're not perfect. On this side it is the standard photographic thread, which is a 1/4 or 21/4, which is there. So I'm going to fix my guiding bar on with some 1/4 screws. I don't know if you can hear this, it's making some weird noises when I screw these in. I guess it's just the rubber inside there, but listen to this. And I'm not doing that tightly, that's, you know, just very, very weird noises. Anyway, that's it. There is the telescope. With its mounting circles there. Interesting alignment. I don't think these are amazing by any means, but at this price bracket it's pretty much on par with what I would expect. So this will be where my guide scope will mount, and this one I will use to mount the telescope on the actual EQ mount. Another unboxing, and this one is not in the original box. This is something which is second hand, which I have picked up. Let's see what we've got. This is something, I'll give you a little hint, which I've actually been interested in getting for quite some time. Ta-da! It's a mount. Okay, first thing with any Skywatcher mount that you check is whether the previous owner has bent these bolts. So you loosen them and you undo them. Oh yes, they're not bent. Okay, this is an EQ3 mount and it is second hand. It has the right ascension and declination motors there, and it's broken. The owner said that this is broken and the motors don't work, so I need to fix that. But it's an EQ3 mount. It could be the answer to being a portable, lightweight mount. Aha, okay, now it makes more sense. The screw is from the eyepiece holder and it would have been in there. These motors should be fine, and I can test this hopefully with my EQ5 Pro. I've got this very odd fault where the stepper motors, this one is for the right ascension, and the one in here, just in here, is for the declination. And I've basically plugged everything up, and although one of the cables has come off, but that's not the issue here. The soldering on this is really bad. You can see that if I get that to focus just on there, you can see that there are two bits of solder there which are really poorly done, and also there's continuity between these two pins, and I don't know why that is the case. So I think what I'm going to do is replace this DIN plug here. But if you listen to this, it's pretty scary. It's it kind of stalls the motor, and then this one is horrible as well. It's not actually grinding. I know that sounds a bit weird, and it sounds like it's grinding. It's actually the stepper motor having an issue. So I am going to first of all fix the soldering here and replace this DIN plug. That's my first job, to replace this connector. So I've got some replacement DIN connectors which you see here, they are absolutely the same from what I can see as the ones that you get with an actual mount. And I've basically got to transfer each of these cables onto the equivalent pin on this connector here, because these two just here have got continuity between them and I don't know why. So I'm just going to buzz through these again with my multimeter, and one there. They've got continuity, which they shouldn't have. So therefore, I'm going to transfer each of these cables onto their corresponding pin on this one. There we go, I've resoldered all of the connections, and now I'm just going to put the heat shrink on, and then I can give this new connector a test. This is my stepper motor test jig. I've got an Arduino, which I've programmed with a little bit of code, which I just found on the internet, to run a stepper motor backwards and forwards, as you can see. And then I've got a stepper motor driver here, and I've got a power supply for the stepper motor driver and a power supply for the Arduino. Now this is a typical stepper motor. It's a lot bigger than the ones that I've got in the EQ mount. However, the principle is exactly the same, and I used this setup to test that the motors were working in the EQ mount. Now sometimes you have to find out which of these four connectors are the ones that are driving the individual coils in here. And the way you do this, normally you can just take a stepper motor and you can turn the axle like that. If you want to identify the coils, all you have to do is take one of the wires, doesn't matter which one, and you just join them together with your fingers. And if it gets too hard to turn, then that one's easy, I can turn. I'll put the blue one on, that one's easy to turn. There you go, I can't turn it now because this has shorted out the coil and it prevents the motor from turning. So the green and black are one coil on this particular motor, and then I would imagine the red and blue here are, yep, I can't turn it, and no, I can turn it. So basically you just short out the wires to identify the two coils, and then you can wire it into your test circuit here using an Arduino and some code and a stepper motor driver. And this is how I tested the EQ3 motors to prove they're working. And you can see it works really well in both directions, and this piece of tape is just an indicator. So that was how I tested it. Here it is, the repaired EQ3 mount. Unfortunately, the original controller, motor controller here, the two stepper drivers were blown, which is why the stepper motors didn't work. When the tripod was in transit, the box became damaged and it lost the counterweights and also these cables. Luckily, these cables are just normal 8-pin DIN cables, so they're available from Amazon very easily. They're about £8. Although I've had to replace these cables here, this is the socket which I replaced, and it's working beautifully now, and of course that's all been properly soldered inside and there are no more shorts and everything is working properly. The person who sold me this gave me a little bit of money back, not as much as I would have liked, but I managed to get a bit of money back for the counterweights. So I now have two EQ3 counterweights, which we've got, and of course a brand new computer. Now I had budgeted for this computer, I hadn't really budgeted for the weights or the cables, but you know, these things happen, and I'm, you know, it's about £15 out of pocket, which is not much, so I kind of budgeted for all of that. I did replace these bolts on the side because the ones that Skywatcher give you are really short, and I wanted some longer ones, which makes it far easier to do polar alignment. I'm not going to be replacing the latitude bolts here because they're absolutely fine. I'm quite impressed with these. And one thing which is really nice is how it sounds. I've also tuned the worm gears on both the right ascension and the declination, and it sounds fabulous. Listen to this. Doesn't that sound nice? So it's really good. So I just flew to M31. The whole thing's working really well, and I'm hoping to use this as a portable mount because look how easy it is to lift. I mean, it's just so light, which is really useful. So I'm going to put my Altair 60 EDF on here with a camera and leave it permanently rigged, and then this can be a really quick rigging scope which I can just lift outside if it's clear, switch on and do some quite wide field shots with it. So I'm quite excited by what this mount will be able to give me.